Now we just finished that. Now we're gonna try to do some advanced problem using the one we already did. So before we do the advanced problem, let's recap everything by discussing the Newton law of motion. So Newton law of motion is fundamental to understanding the classical mechanics. Newton law of motion. There are three set of law. Number one, we call it Newton first law, Newton first law, or law of inertia. Okay, so what law of inertia tell us? Law of inertia tell us that if the net force of an object is 0, if the net force of an object is 0, then object at rest remain at rest, and object at motion remain at motion with straight line and constant velocity. Okay, so what would be the example? Let me give you a conceptual example, then go more math, then we'll do the more math example. Let's do conceptual example of this one. Let's say suddenly the gravity, we've been talking of the gravity all along. So let's say the gravity between Earth and Sun disappear suddenly. What's going to happen? What the Earth will do if the gravity between Sun and Earth disappear without any notice? What's going to happen? The Earth, the Sun is here, big Sun, and the Earth is here, right? So now the Earth is moving, orbiting around the Sun, right? 24/7, non-stop. But because why? Because there is a invisible force, we call it gravity. That's why the Earth orbiting around the Sun. What if the gravity disappear, suddenly disappear? The Earth is still orbiting around the Sun. Now the Earth will, as soon as the gravity disappear, the Earth will leave the solar system. How? With a straight line in a constant velocity. As soon as the gravity disappear, the Earth will move like that. It will leave the solar system with a straight line, in a straight line with constant velocity. That's what the Newton first law tells us. We'll do more math example to understand Newton first law, but if you understand this much now, you are in a good shape. So Newton's second law. What is Newton's second law? Newton's second law is more famous than any other law. In fact, I use the Newton's second law on the cover of my book, which tells us that our ancestors were kind of monkeys. So the idea is that they benefited by Newton's mathematics and classical mechanics, and they evolved from beast to beautiful. So the main idea is the F equal ma, which is Newton's second law, led to the Industrial Revolution. Industrial Revolution. Led to the Industrial Revolution, remove all those darkness and you know, and the modern time begins thanks to Newton's second law. Okay, so what Newton's second law tells? Newton's second law tells us that force is proportional to mass times acceleration, or acceleration is proportional to the force and inversely proportional to the mass. Okay, so acceleration, as we talked before, is a vector quantity. Force is a vector quantity, but mass is not a vector quantity. Mass doesn't have more than one component. All right. So number three, we can say Newton. We can state Newton's third law. What is Newton's third law? Newton's third law, you know, conceptually we know that every action there is equal and opposite reaction. But that's what we're going to write? No, that's not going to help us too much. So we're going to write the appropriate definition. All right. If an object A exert force on object B, then object B exert force on object A, which is equal in magnitude but opposite in direction. Okay, so what does that mean? How can we write it? How can we convert it into more, you know, into more math equation? We can simply write Newton's third law is F AB equal F minus AB. Okay? So if object A, if object A exerts some force on object B, then object B also exerts some force on object A, which is equal in magnitude but opposite in direction. So that's what it means, opposite in direction. Okay, so that's the negative sign means. It's equal in magnitude but opposite in direction. So what is the conceptual example we can come out to understand Newton's third law? Well, scientists used nothing but Newton's third law to land the man on the moon in 1969. So they use only Newton's third law to land Neil Armstrong on the moon in 1969. How that happened? So if you have a space shuttle, right? If it is Apollo 11, so what Apollo 11 does, it exerts a lot of gases. All right, so it exerts a lot of gases, and then gas also exert a lot of forces. So this is A, this is A, this is B. All right? A exert gases, B exert forces, which is equal in magnitude but opposite in direction. So the space shuttle go up and the gas go down. All right. And which is equal in magnitude, opposite in direction. That's how the space shuttle can go its destination, and that's all scientists use to land the man on the moon in 1969.